Now we'll discuss about electrical safety. Electrical safety in medical environment, that is basic protection mechanisms for patient, operator and the third persons. So this medical technology has improved healthcare in all medical specialties with rising complexities. The purpose of safety testing medical electronic equipment is to ensure that the device is safe from electrical hazards to patients and maintenance personnel and users. Electrical safety in hospitals is shared responsibility between several parties, physician including the nurses, all engineers and the manufacturers. The critical points to be checked in electrical safety is the electrical installation, no matter how safe, is the only part of safety requirements. Plugs and cords must be checked and rejected if defective. Patients' leads must be attached and connected properly. Radio frequency devices must be excluded. Ground wire integrity, ground wire leakage, and the basic electrical characteristic usually causes the most leakage currents. Next is the electric shock hazards. So it's a common experience that hazards due to electric shock is associated with equipment other than that used in hospitals. The patient may not be usually able to react the normal way. He is either ill, unconscious or strapped. He may not be able to withdraw himself from the electrified object when feeling a tingling in his skin before any danger of electrocution occurs. So considerable nature protection and barrier to electric current is provided by human skin. Such situations arises when the tests are carried out on the subjects with a catheter and his heart or on large blood vessels. An interruption in the power supply or failure of the equipment may give rise to hazards. So it is also obvious that optimum level of safety can only be achieved when efforts are made to include safety measures in the equipment. There are two situations account hazards from electric shock: gross shock, microcurrent shock. Gross shock, the current flows through the body of the subject. Microcurrent shock is current passes directly through the heart valve. So here even very small amount of currents can produce fatal results. Gross shock, it is experienced by the subject by accidental contact with the electric wiring at any point on the surface of the body. So in all these cases, the body acts as a volume conductor at the main frequency. So the current must enter the body at one point and leave at some other point. This phenomenon can occur under electrical stimulation of the excitable tissues, nerves and muscles, resistive heating of tissues, electrochemical burns and tissue damages for direct current and very high voltages. Effects of electric current on human body, that is threshold of perception, let go current, physical injury and pain, ventricular fibrillation, sustained myocardial contraction, burns and physical injury. Microcurrent shocks, that is, the threshold of sensation of electric current differs widely between current supplied arm to arm and current supplied internally to the body. So here such situations are commonly encountered in hospitals. So this is the effect of various levels of current on the human body: 1, 2, 3, 4, 5 and 6. 1 is the threshold for perception, 2 is the let go current, 3 is the respiratory paralysis, fatigue and pain, 4 is the ventricular fibrillation, 5 is the sustained myocardial contraction, 6 is the brains and injuries. And the current and the effects of current: 1 milliampere means tingling sensation, threshold of perception; 5 milliamperes means light shock felt, not painful but disturbing; 6 to 20 milliamps painful shock let go range; 50 milliamperes extreme pain respiratory arrest; 100 milliamperes ventricular fibrillation; greater than 5 amperes it is possible burn, sustained myocardial contraction, respiratory paralysis and portable death. Leakage currents. So currents of extremely small magnitude can be fatal to a patient when a direct, localized electric path exists to the heart. This leakage current is inherent flow of non-functional current from the live electrical parts of an instrument to the accessible mental parts. The major source of potentially lethal currents in any instrument or leakage current. The leakage currents due to capacitance between any two conductors separated in space. And the resistive component of the leakage current arises because no substance is the perfect insulator and some small amount of current will always flow through it. So types of leakage current: enclosure leakage current, earth leakage current, patient leakage current. So here is the diagram, shows the path of leakage current in a normal case and path of leakage current in case of discontinuous ground. Precautions to minimize electric hazards, that is, in the vicinity of the patient, use only apparatus, three-wheeled, three-wired power cords, and have periodic checks of ground wire continuity. Staff should be trained to recognize potentially hazardous conditions. Connectors for probes and leads should be standardized so that the currents intended for powering transducers are not given to the leads applied to pick up psychological electric impulses. Thank you.